Hello everyone, my name is Rocky Greiner. I've developed a new type, or I designed a new type of swivel. I call it the ultimate swivel because it eliminates a lot of the problems that the swivels on the market today have. Every swivel that's available today that you can purchase has a problem to it. I call it an eccentric, or there's parts or positions that you strike the bag that it doesn't operate as efficiently as it does in a certain direction. This swivel of mine, and I'm going to show you, this is a cross-section of the swivel. This is twice the size of this mock-up. Now this is a mock-up of the swivel. I'll show you how it operates from the mock-up. This is made out of ping pong balls, and you'll understand in a moment why it's made this way. It'd be very difficult to make. I designed this, I came up with this in 1999, but at that time, because of manufacturing processes, it would be very expensive to make. So I never did have it made. But here's the way it operates. First of all, a ball, a sphere, you might call it, a solid sphere, it could be stainless steel or any type of material, vinyl or plastic, so forth, is attached to an element that screws into a fixture on your platform of a speed bag. Now this ball or sphere is fixed. This does not move. It's completely different than the swivels today, where you have a spherical object that moves in sort of a socket and it moves back and forth. So the sphere does not move. But there are two elements that move about the sphere, and both of those elements move about the center point of that sphere. So when this rebounds back and forth or sideways in any direction, say 360 degrees around the platform that you hit the bag, it'll always rotate. Those elements will rotate about a single point, not an axis. Like today's swivels and all of them that are available, they will move about an axis. And this moves about a single point. Both of these elements move about the same point. So here's how it works. There's a lower element, and this is a cup-shaped element, I'll point it out, with the hook attached to it. Now it looks like this in reality. This is a cup-shaped element with a hook on it. This rotates about the sphere with a hook on it, just like this element, if you got the picture. Now, capturing that element is a spherical element. You can see it in red. I don't know if it'll come out in color on your movie, but it's a sphere that's been cut, sliced off the top and the bottom, and it's been cut in two, wrapped around the original solid unmovable sphere, and it captures this lower element. So both of these elements can rotate. Now if you get the picture, if this rotates and you strike the bag, let's do it in this direction. If you rotate it this way, the outside sphere will hit, and that forms an angle of 40 degrees. And all of the spherical shaped type swivels today that operate with a spherical element in a socket will rotate just 40 degrees. But this unique idea of having this other element captured in size, it can rotate until it's right parallel with the platform. In other words, the bag does not ever move or slide on the hook. You can duct tape the strap of the bag to the hook, and it will always move in any direction in about 360 degrees when it's mounted on the platform, and you don't have any eccentrics. So it's a beautiful swivel. It's flawless, but here's the way it'd have to be made. First of all, you could make an element like this. See, this is made out of aluminum. This was taken from an inexpensive swivel, and it was just cut off. So it would be less than half of the radius of the sphere that this fits in, if you got the picture. That's this lower element with the hook. Now this one would have to be made out of a hollow ball that's cut off at the top and the bottom and sliced in two, put around this, and then tack welded on. So that's the way it would have to be made. It's rather complicated. In 1999, you'd have to make it with tools and dies. Just the dies alone to make these parts would probably cost thousands of dollars. and there's simply not a big enough market. But anyway, that it could have been made, but today, with the processes today, with the automatic manufacturing type machines that they have today, they're computer operated, it automatically could make these parts. Or if someone wanted to really invest some money, there are companies that will manufacture hollow balls of different sizes that you want and out of different materials. So these could be manufactured. It's an expensive process, and you'd have to have a number of balls made to really make it worthwhile. So it'd take quite an investment. But nevertheless, I'll show you now a cross section so you get a little better idea of how this thing works. Now, if you look at the cross section, this is the fixed ball or sphere. That is fixed. And this element is screws into your fitting that's on the platform. Now, the way it operates is, this is the outer shell or outer sphere that's cut off top and bottom. And there is the inner cup-shaped sphere that's like this element with the hook on it. And you can see, but just to make this thing simply, this element is attached to the sphere, but the sphere in reality doesn't work. But anyway, as this rotates, I'll hold it and show you how it rotates. As this outer one rotates, it hits the pin, and then this lower sphere, or cup-shaped sphere, can rotate an extra 20 degrees. Normally, without this element pivoting inside of the outer shell, it would stop at 40 degrees. It would make an angle of 40 degrees with the platform, and the bag would have to slide on the hook. And this is eliminated by the fact that this can rotate an extra 20 degrees. You can actually go parallel with the platform. So if this is parallel with the platform, then you can take the strap of the bag, duct tape it on that hook, and that will never have to move. And it can move, of course, in any direction. It can move in this plane, or any plane, 360, and these two elements always rotate about a point. There are no axes involved, and that's the beauty of it. And so if there's someone out there that has access to that type of manufacturing machinery, that it could be made with these computer-operated machines that they have today, or wants to make a substantial investment and order balls and spheres that are made, and you can see that it takes some dimensional problems of getting a close fit, and they have to be different diameters and different inside diameters and so forth to make this operate properly. It takes a little doing to do it, but it would really be a fantastic swivel if someone out there would make it. I'd really be delighted if someone would do this. Of course, this could have other applications too. You can see that the camera here is mounted on a tripod, and it's got two axes. It's got a vertical axis that you can rotate it this way, and then there's an axis that rotates the camera this way, back and up and down, and one side to side. Now, if you had this and the camera was mounted on this, you could just point it in any direction and fix up a screwing mechanism. So it would really be beautiful. You could not only use that for a camera mount, I mean, you could use it on a crane, you could use it for military application, you could put a weapon on it. It would really be a fantastic device. You could probably found an industry on this type of a simple swivel, or a hinge if you want to call it a hinge. But anyway, it worked for me. I'd rather see it on a Speedbag, and I'd rather see it manufactured and made at a reasonable price that people could actually use it, because I don't think a better swivel could be produced. It's absolutely flawless. There are no axes involved. Now, I could point out another thing by going back to the cross-section. You can see that this outer shell, or you might say the big spherical element, would strike up here and hit the pin that holds the solid sphere to this in one uniform piece. This would have to be a separate element, or it could be a ball bearing race to make it, to cut the friction down. So this could be a ball bearing race, or it could be like a ring-shaped element whose inside is contoured to the shape of the sphere, so it would rotate about the sphere with the least amount of friction. Anyway, there you have it. I hope someone out there sees this design and would manufacture one. I think it'd make fantastic swivel for a speed bag. I'm in my 90s now, so believe me, to get going on a project like this would take a number of years, but someone out there that's got access to this type of machinery and wanted to put some effort into it could come up with really a great swivel. Plus it has other applications, so someone could be very successful with this idea. I hope they take it, and I hope they use it, and good luck to you out there, and God bless.